Very good. I'm proud of you. All right. So take a look at that picture right there in the starter question. And the first question is, what formula relates the sides of this triangle? Yeah, you could use the Pythagorean Theorem, okay? So I'm going to say c squared equals a squared plus b squared. Just going to write it a little bit backwards, just for convenience here. So that works if it's a right triangle. And I'm calling that right angle gamma. So what would happen to side C? What would happen to the hypotenuse if gamma got bigger? So if I made this a little bit bigger, what would happen to gamma? Or sorry, side C. Okay, it would get bigger, right? And what would happen if I made gamma a little bit smaller? So I shrunk that down just a little bit. So it wasn't a 90-degree angle, it was a little bit smaller. Okay, it would get smaller, right? Okay, so side C would get smaller based on the size of how big that right angle, in quotes, is supposed to be. So this gets to the idea behind the law of cosines. So the law of cosines is an adjustment on the Pythagorean theorem. Okay, what it does is it accounts for making that right angle right here get a little bit bigger or a little bit smaller than it usually is. So if it's a right angle, then we've just got the Pythagorean theorem. If it gets a little bit bigger or a little bit smaller, then we need to make an adjustment on the Pythagorean theorem, and we need to make that adjustment based on how big that angle is. Okay? So if you're interested in how to derive the law of cosines, we could certainly do that. You can also find plenty of videos on YouTube or Khan Academy and things like that. But here's what the adjustment looks like. So it starts out with a c squared just like it normally does. I've got an a squared and a b squared, and here's the adjustment. I subtract 2ab times the cosine of gamma. Now, you can memorize 3 different formulas for this, okay? And in this book, I think sometimes they'd call this side C. I kind of like using the Greek letters. That's a little bit more standard, okay? You'll notice that it starts with the side. Everything else in between is the other 2 sides, and it ends with the angle that created that side. So if we look at this right here, we could adjust this just a little bit. What if I wanted to find side A? What if A was across from what used to be a right angle? Well, then it would be b squared plus c squared, and then minus 2bc, and then the cosine of what angle creates side A? Alpha. So again, starts with the side, ends with the angle that created that side, and everything else in between are the other 2 sides. So if we started with side B, what angle would we end with? Angle beta. And everything in between would have to do with the other 2 sides. So this is going to be A and C. So my question for you is, and I think this is enough to understand what's behind the law of cosines, why is it a minus right here rather than a plus? And to figure that out, let's consider, what if gamma was, let me write that a little better. What if gamma was, let's say it was 110 degrees. Is the cosine, now we said this is going to get bigger, right? Let's say that was 110 degrees. Cosine of 110, is that positive or negative? Cosine of 110 would be the adjacent side of the x-coordinate in the second quadrant, right? Positive or negative? It's going to be negative. So if this was negative, I'd have a minus times a minus. What would that be? It would be positive. I'd be adding a little bit. Okay? What if gamma was 80 degrees? It's positive, so I'd change this to a positive, so I'd be subtracting a little bit. So if it's larger than 90, that minus makes sure I'm adding something, and if it's smaller than 90, it makes sure I'm subtracting something from what used to be the hypotenuse. Does that make sense? Okay, so that's the idea behind it, and when you're doing these problems, just like I mentioned before, there's really no substitute for thinking about how these things are related, okay? How the sides and the angles are related. So there's something called the triangle inequality, Okay, and I would imagine everybody in here has seen this before, but let me just remind you of what it is. I've got a blank here, and it says, the sum of any two sides of a triangle must be blank the third side. Take any two sides on any triangle, and they have to be what compared to the third side? They have to be greater. They have to be bigger. So the easiest way to check this is to add up the two short sides, or the two small sides. They've got to be longer than the third side. So let's take a look at an example right here. I've got 3, 5, and 8. It says figure out the number of triangles with the given parts. So 3, 5, and 8. 3, 5, and 8. Can I make a triangle like that? The answer to that is no, I can't. So I'm going to illustrate it this way. Let's say this is 8, and let's say this is 5, and let's say this is 3. If I swing these together to try and make a triangle, they're just barely going to touch when I lay the 3 side here and the 5 side here. They're just barely going to touch. And if I raise them up at all in order to make a triangle, they'll come apart. Okay? So even if the two short sides add up to equal the long side, that's not enough to make a triangle. They've got to add up to something that would be greater. So if I've got 10, 5, and 8, 10, 5, and 8, take the two short sides, add them up. That's 13. It's bigger than this one, so I'm going to get a triangle right there. Okay? So 10 here, 5 here, and 8 here. Okay? I'm only going to get one triangle for that. I've got alpha is 28, beta is 92, and gamma is 70, and side C is 16. So I've got angle, angle, angle. I've got all three angles, and I've got a side. Anything wrong here? They add up to, if you add them up, they add up to 190. Okay, can you make a triangle? Okay. No triangle. So no triangle here and no triangle there, but for different reasons. Okay? Okay, so again, just a reminder, regardless of what you've been given, make sure you think about how the sides are related to the angles. Okay? What you should expect and that sort of thing. Okay? And we're always going to draw a triangle. And we may have to draw more than one in order to get it right. So solve the triangle using the given information. I've got alpha is 121.3. Side B is 2.9. Side C is 3.1. So think about what we've got here. Do we have an ambiguous case? Do we have something where we could draw this roughly to scale and figure out, you know what, I know exactly what's going on here. It's not acute, so that's good. Okay, where is alpha with respect to sides B and C? Remember, the names mean something. This is side B, this is side C. Let's go up here and take a look at this. Side B and side C, what's the angle that's right in between there? Alpha, because if this is side B and C, side A's got to be across from it. That means alpha's got to be right in between it. Okay, so on this one, we're given a side, an angle, and a side. That's what we've got. So if I draw that, this is 121.3 degrees. This side I'm going to make 2.9, and this side I'm going to make 3.1. Okay, I can make a triangle out of that. All I've got to do is figure out how long the side is that goes from here to here, right? Any questions? Okay, so what I'm missing here is side A. but I do have the other two sides, and I have the angle that created that side. And think about how this was set up. Think about how the law of cosines was set up. It started with a side, ended with the angle that created that side, and everything in between had to do with the other two sides. So I need side A, and I know how big angle alpha is, and I have B and C. So I'm going to use A squared equals B squared plus C squared minus 2BC times the cosine of alpha, which on this problem is A squared, 2.9 squared, 3.1 squared minus 2 times 2.9 times 3.1 times the cosine of 121.3. Now, that's a little bit of a pain in the butt to write, but I've got all the pieces I need, and if I wanted to figure out what A was, I'd just take the square root of that. So I'll grab the calculator, you grab your calculator. Let's punch this stuff in here. So I'm just going to do a big square root, 2.9 squared plus 3.1 squared minus 2 times 2.9 times 3.1 times the cosine of 121.3. I think I'm in degree mode, so I should be in pretty good shape. Let me double check that. I am. Okay. So I get that the square root of that ugly mess is 5.23076. Okay, now, I haven't used this book before. I'm not sure what it's going to do, but here's where you'd want to be a little bit careful. If I were asked, what is the answer? How long is side A? What would I say? 5.2-ish, somewhere around there. Depends on what you want to round to and what the instructions say, right? So we could say this is going to be about 5.2. I'd rather you round at least to the hundredths place, so we're going to call that 5.23. What I'm missing here, because this is side B and this is side C, is I'm missing gamma and I'm missing beta. Now, how do you find gamma and beta here? Okay, probably the easiest thing to do here is to use the law of sines. So if I set this up using the law of sines, here's what I'm going to do. I'm going to find beta. So I'm going to say the sine of beta over 2.9 is equal to the sine of 121.3 over, what would I put here? Okay, I'm going to use a lot of decimal accuracy. In fact, I might even store that in the calculator and use it. I'm going to use lots of places of accuracy. Now, if you get an answer that's slightly off from the back of the book, okay, don't worry about it too much. Maybe they rounded before they used that. I think this is a much better way to do this. Okay, use that more accurate answer. Now, everybody listen carefully, please. Take a good look at this. I'm going to use sine inverse to solve this. And it's going to be sine inverse 2.9, sine 121.3 over 50 or 5.23076. Do I need to worry about the calculator giving me an answer where, gosh, that might be the right answer, or maybe I need to do 180 minus that answer to get the correct angle? Do I need to worry about that here? I see some shaking heads. No, that's right. Somebody tell me why no is the right answer here. Because this angle right here is obtuse. What does that guarantee us the two of these are going to be? They're going to be acute. Okay? What'd you end up with? Anyone? 28.27? Okay. So this is 28.27 degrees. And I've got that side right there. And the only angle left is this one right here, which I can find by subtraction, right? Piece of cake? Okay. Take a look at the next one, please. No diagram. What have we got here? Which of these? Side, side, side. What should we check and make sure of? Do we get a triangle? Yeah, these are all about the same length. I mean, you could add the two short ones together. We definitely get something that's bigger than 7.1. Since these are all really close in length, can somebody make a prediction about the angles in this triangle that we're going to find? They're all going to be acute, and they're all going to be pretty close to the same. Okay? Because these are so close, they're all going to be pretty close to somewhere around 60 degrees. So here's what we're going to do. Okay, I'm going to label this as 6.3. That's going to be A. I'm going to label this as 7.1. That's going to be B. And this is going to be side C at 6.8. So I'm missing gamma, or you could call it angle capital C. This would be alpha, and this would be beta. Law of Sines is pretty easy to use, but can we use it here? Can't. Okay? So pick one right here. I'm going to use this one. I'm going to use c squared equals a squared plus b squared minus 2ab and times the cosine of gamma. And let's find gamma here. So if I've got 6.8 squared, this would be 6.3 squared. This would be 7.1 squared. And then we're just going to subtract these when we multiply them by 2. Whoops, that should be a 3 times the cosine of gamma. And I want to solve for this. So what do I do? Not yet. What's that? We might use a square root in here. But is it necessary on this one? Here's the variable, right? What do we normally do when we're solving an equation? We isolate the variable term. So the first thing I'm going to do is I'm going to move those to the other side. Okay, and if you would please resist the temptation to square these out and start writing down big, long, ugly decimals. Going to be a lot easier in the long run if you leave them like this. And then I need to get rid of the timesing by -2 times 6.3 times 7.1. So I'm going to divide by -2 times 6.3 times 7.1. So that stuff is gone. How do I finally uncover what gamma is? Cosine inverse. So gamma is going to equal the cosine inverse of this ugly mess right here. So 6.8 squared, that's a 6.3. 7.1 squared, and then we're going to divide by -2, 6.3, 7.1, and we're going to type that into the calculator. Okay, again, I'm in degree mode, so I'm all set to go. So I'm going to type in cosine inverse. Okay, what do I need next? Okay, this numerator has 3 different terms in it, so I'm going to do parentheses, 6.8 squared minus 6.3 squared minus 7.1 squared. Close the parentheses, that'll close the top, then divide, and then we put the denominator in parentheses. So -2 parentheses, or we can just do times, 6.3 times 7.1. Close the parentheses for the bottom, close them again. What type of answer were we expecting? We're expecting an acute angle. We're expecting, well, let's see, if I was finding alpha, that would be the smallest angle. This is the medium side, so it should be somewhere right around 60, and let's see what we get. 60.64, okay? So 60.64 degrees. Any questions? Okay, what should we do to find the other angles? Okay, you could use the law of sines. Everybody watch, please. Okay, need your eyes up here. Can you use the law of sines now? Yeah. Yes, you can, because you've got these two that correspond. You can set them up to find alpha and then find beta, okay, by subtraction if you want. Okay, please watch. Okay, I'd like to suggest that especially if you're not, if the diagram doesn't quite look right or you're not quite sure, Why might it be a good idea to use the law of cosines again, even though this looks a little bit longer? Yes.
So you can get an exact answer.
Okay, so you can get an exact answer and you don't have any rounding. I'll take that one. Okay, let me show you something else, and then let me show you something that you'd need to think about for a little while. Okay, let me pull this up. If I were going to find, say I wanted to find alpha next. Alpha is going to be the smallest angle. What I do is let's see, it would be a squared equals b squared plus c squared minus 2bc cosine alpha, right? And if I plug those things in, this is a 6.3 squared. This is a 7.1 squared. Actually, I'm going to write them. I'll write a 6.8 squared, 7.1 squared, 6.8, 7.1 cosine alpha. Okay, compare this with this right here. What's the difference? Besides the fact that it just disappeared. Yeah, the 6.3 and the 6.8 got switched, right? So on your calculator, what if you just recalled this and I went through and I said this? Let's make that a 6.3. Let's make that a 6.8. Let's jump down here. Let's make that a 6.8. And I hit enter. So all I had to do is just recall that, edit the command, and I end up with 53.85. So 53.85 degrees. And that is the right answer. Yeah, if you had to write out all this stuff, this is a lot longer than the law of sines, okay? But again, that makes it a little bit easier. Why might it also be better to use the law of cosines instead of the law of sines? If you didn't have any of these other angles yet, or maybe this was a pretty tiny angle in particular. What is the range for cosine inverse? 0 to 180. Would it cover all of the angles in a triangle? Yep. You wouldn't have to worry about, oh my gosh, I got this angle and it was acute when the answer was actually obtuse. Okay? That's especially helpful, like if you picked the wrong combination here, okay? And say this was a pretty tiny angle right here and one of these turned out to be obtuse. If you found the obtuse one using the law of sines, okay, first of all, you'd get an acute answer and you'd think, oh, that's just it. So you've got to think about how big the angles are with respect to the sides and all that sort of stuff. The law of cosines actually in the long run is one that would be, they're both good to be familiar with, okay, but the law of sines, there's that ambiguity in there that we don't have with the law of cosines, okay? All right, finish up 6.1. Start, let's see, I haven't given you the assignment, so finish up 6.1 and then make sure you look at your notes for 6.2. We'll finish that tomorrow and I'll give you the assignment, okay? What's that? 6.1's due tomorrow, okay? We'll correct that first thing.